Today, we're going to meet the invisible guardians of your medicine cabinet. And no, they're not chemists, they're data detectives. And they might just be the most important people in healthcare that you've never even heard of.
Have you ever stopped to think about it? You pop a pill and you just trust it. But how do we really know it has the right dose, that it's actually going to work? And, the big one, that it's safe. It's a question we all just assume has a good answer.
Well, you might think the secret is all bubbling beakers and lab coats, right? But the real confidence, the proof, it comes from somewhere else entirely. It's a place that sifts through mountains of information to find the truth. The answer is hidden deep inside the data.
Okay, so picture this. Scientists create a brilliant, promising new drug. But before it can ever get to you, it has to go through tons and tons of tests. And every single test, every trial, every single batch produces this massive, chaotic pile of raw data. So how in the world do you make sense of all of that?
This is where our hero comes in, biostatistics. It's a specialized science that's all about applying statistical tools to medical data. The people who do this, biostatisticians, they're the data detectives who turn all that chaos into pure clarity. They're the ones making sure our treatments are safe and effective.
So how do they actually do it? Well, let's open up their toolkit. The very first job is to tame all that data chaos. And for that, they use a really fundamental tool called a frequency distribution.
I mean, just look at this. This is what raw data looks like from a simple quality control test. They're just measuring the weight of pills in milligrams. It's a total jumble of numbers. It's impossible to see any kind of pattern or, draw any conclusion from this mess.
So how do you fix this mess? You bring order to it. Our data detectives follow a pretty simple process. First, they just line all the numbers up. Then, they group them into logical buckets, like, say, all the pills that weigh between 247 and 249 milligrams go in one bucket, and so on. And finally, they just count them up.
And boom, just like that, the random jumble becomes a nice, clean, simple table. Now we can see the pattern instantly. Most of the tablets, 4 of them, weigh between 250 and 252 milligrams. The chaos is gone, and we're left with clarity.
All right, so the data is organized. The next step is to find its center. Statisticians have a fancy name for this, central tendency, but really it's all about figuring out what a typical value looks like.
The first tool is one you definitely already know, the mean. Yep, it's just the good old average we all learned about in school. You add everything up, divide, and you get a really great overall picture of what's going on.
But what if you have a real wild card in your data? Like one number that's way, way higher or lower than the rest. That can totally throw off the mean. So for that, detectives use the median. You just line up the data, and it's the value sitting smack dab in the middle. It's not bothered by those weird outliers at all.
And then, for a completely different question, like what was the most common result, they use the mode. It's literally just the value that shows up most often. This is perfect if you want to find something like the most frequent side effect, for example.
So, mean, median, or mode. Which one's the best? Well, that's where the detective work really comes into play. A smart data detective knows you have to pick the right tool for the job. If the data is all nice and balanced, the mean works great. But if there's an outlier, one pill that's way too heavy or light, it can really skew that average. In a case like that, the median is going to give you a much more trustworthy picture of the center.
But hang on, finding the average, that typical value, is really only half the story. To truly know if a medicine is safe, we need to look at its consistency. And for that, we need our third set of tools, measures of dispersion.
So let me ask you a question. Let's say a batch of pills has a perfect average dose, let's say 100 milligrams. Does that automatically mean it's safe for patients?
The answer is a huge, resounding no. Look at this. Both of these curves have the exact same average right in the middle. But that wider, flatter curve, that's dangerous. It means that while the average dose might be correct, some pills could have way too little medicine, and others might have a dangerously high amount. Consistency is absolutely everything.
The key tool for measuring this is called standard deviation. Now, it's a single number that tells you exactly how consistent the data is. A small standard deviation is what you want. It means every single pill is almost exactly the same. It means reliability. It means safety.
Now, the formula for standard deviation, I'll admit, it can look a little scary. I get it. But don't worry, it's not magic. It's just a really logical, step-by-step recipe that anyone can follow to measure consistency. Let's just break it down real quick.
So the recipe is actually pretty simple. You start with the average. Then, for each pill, you measure how far its weight is from that average. You do a little bit of math to handle the positive and negative differences, and then you basically find the average of those measurements.
The very last step is taking the square root, and what you're left with is this, one single number, 2.83. And this one number, it tells the entire story. It's the data detective's final verdict on how consistent, and because of that, how safe, the entire batch of medicine really is.
So, let's put it all together. These tools, they're not just for boring academic papers. They are the invisible guardians standing between you and potentially unsafe medicine.
I mean, think about the whole journey. From a chaotic pile of data, these detectives create order. They find the drug's typical effect, and then, crucially, they use tools like standard deviation to guarantee every single pill is consistent and safe. And their work doesn't even stop there. They keep monitoring for safety long after a drug is on the market.
Just like our source material says, this is a rigorous scientific method. This isn't about hunches or guesswork. It's a systematic process for analyzing data to make those critical, sometimes life or death decisions that protect all of us.
So, the next time you open a medicine bottle, just take a second. Think about those invisible data detectives, the ones who tamed the chaos and did the math, all to prove that what's in your hand is both safe and effective.